Hello students, in this exercise we're going to study how to get PMF, the probability mass function, from known CDF, cumulative distribution function. What is the PMF and CDF? Here's the definition of the probability mass function. Probability where the random variable capital X is taking a numerical value small x. And this is CDF, cumulative distribution function, the probability or a cumulative probability where the capital X, the random variable, is taking a numerical value small x or less. Or less. That allows us to consider cumulative probability. Let's go to the problem, and CDF is given. Please note that everything here is the interval. Negative infinity to 0.25, first interval, all the way to the negative infinity, and the next interval from 0.25 to 0.5, and then 0.5 to 1.25, 1.25 to 2, and then 2 to positive infinity. And then here are the cumulative probabilities, always increasing from 0 to 1. If it doesn't start with 0, or it doesn't end at 1, or it doesn't steadily increase, it comes up and down, then that is not a cumulative distribution function. You see, it's cumulative probability. It's basically you're adding up the probabilities. And the probabilities are always between 0 and 1. And if you just keep adding positive numbers, you should increase your values. So CDF always goes up. And then nothing was added. So start from 0. And then everything was added in, so whole space. So end at 1. Okay, let's begin. How do we get the mass function? Oops. Okay. Let's begin with, all right. Give away a bit too much. Let's begin with some color coding. Again, just to help us out. So less than 0.25, and then that part is not that important. Let's de-emphasize in gray. Everything is greater than negative infinity, so there's no reason to emphasize that part. Okay, the infinity parts are now de-emphasized. And then how about the other numbers? At 0.25, we divide one to the left and then the other to the right. And at 0.5, we divide the interval again. At 1.25, again we have a division. And at x equal to 2, final division. And then this is the right hand side. Okay, this is a bit better, so let's copy and paste this thing. And then please remember, these are cumulative probabilities. So start from 0 and we add something to get 1/3. And then from 1/3 we add something to get 1/2. And from 1/2 we add something to get 1/3 basically. So what am I talking about here? Here this is 0 plus something. That has to be 1/3. And we are looking for this. What did I just add? And then now this is 1/3 plus something was added, so that I get 1/2. You see, it's a accumulation. Something has to be added. I just added this one, and then I just added this one, and then same thing. From 1/2, I just added, so that I get 3/4. And one more thing. So 3/4. I just added something to get x probability equals to 1. Where's brown? And we are looking for these probabilities, P1, P2, P3, and P4. How do I get those? Of course, subtraction. Backward operation of addition is inverse operation of addition is subtraction, so we get these by subtraction. Okay, we have the strategy, so let's go to the answer key. We subtract, and that's a probability mass. We subtract, that's a probability mass. We subtract, that's a probability mass. We subtract, that's a probability mass. And that's the mass function. Actually, I apologize. I overemphasized the probabilities down here and neglected this x part. So let's hide this again. Let's go back to this problem. Okay, started with this and then we did just a bit of a color coding so that I can explain this thing a little bit better. And then note that these are cumulative probabilities, right? So we rewrote like these. And then, okay, what do I want? I want the probability mass function. And then where are the masses? The cutting point here, 0.25, there goes my first mass. And then 0.5, there goes my second mass. And then 1.25, that's the third. And 2.0, that's the fourth. And then finally, all done. Otherwise, probability is always 0. That part is rather trivial. So we have cutting points 0.25, 0.5, 1.25, 2.0. Those are possible x values. Otherwise, the probability is impossible. Now let's find out the probability masses. So I had to add something to get 1/3. So backward operation will be subtraction. I had to add something to get 1/2, so the inverse operation will be subtraction. I had to add something to get 3/4, so we do backward. And then finally, we subtract. And then what are these numbers? What are these probabilities? What are those probability masses? And complete those, and then I'm gonna get the end of the problem. This is 1/3, and this is 1/6. This is 1/4, and finally the probability 1/2. And let's complete the color coding as well. There you go. That'll complete the problem. Now, I did this problem in multiple steps. First, the color coding, and then rewriting the cumulative probability part as an accumulation addition, and then backward operation, and then the answer. But experienced students will go from here to there directly. This part, I just wrote all those things just to help you out. It's not really that necessary. From here, you can go down here directly. So this is accumulation. In order to get what was just added, we go backward and subtract. And that's a probability that you're looking for. And accumulation, we go backward, subtract. That's 1/6. That's a probability. And then we subtract 1/4. Okay, that's a probability mass. And then finally subtract. And that's a probability mass. Round. And That's about it. Because I completed all the computation here, I don't have to rewrite another table. You can go from original problem down here directly. So look at all these intervals and look at the cutting point, 0.25. There. And then cutting point, 0.5. And cutting point, 1.25. And cutting point, 2.0. And finally otherwise. Next, let's go backward. Accumulation is repeated addition. Go backward is subtraction. So we subtract down here. We subtract down here. We subtract and down here and so on. And of course, color coding helps. If you don't use color coding, hey, that's fine too. Experienced students usually go from here to there directly. By the way, let me show you the graphs. The step function, less than 0.25, we have 0, and then 1/3, 1/2, 3/4, and 1, and we are looking for this step size, jump. And those are the probability masses. And is there a graph? Okay, here's a graph as well. Yeah, 0.25, 0.5, 1.25, 2.0, and then the height are the probabilities. 3/4, 1/3, 1/6, 1/4, and another 1/4. Oh? Oh yes, 1/4 is right. Why was I thinking about 1/2? Computation here is correct. Did I get 1/2 before? No, I don't think so. Okay, that completes the problem. Maybe I was affected by the previous problem. In this problem, 1/2 appeared, I think, yes. I kept the same x values, but I changed the probabilities around. And therefore, we have different CDF and CPMF, different probability distribution.